knows the storm is coming fast, the day will soon be here, when those who are caught unprepared will be the first to fall, that much is clear.
Hello and welcome to Physical Attraction, the TEOTWAWKI specials, where we'll be examining the end of the world, one apocalypse at a time.
And survive while there's people crying, people dying everywhere around.
This is Physical Attraction, the TEOTWAWKI specials, where we're dealing with apocalyptic scenarios, one apocalypse at a time. Having now basically dismissed the possibility for earthquakes to result in the destruction of human civilization by themselves, we look at another geological phenomenon caused by magma in the mantle of the Earth. Supervolcano Eruption. So you're happily walking in Yellowstone National Park when suddenly, and without warning, there's this terrible rumbling from beneath. Suddenly the ground below you splits open, revealing layers of hot magma buried beneath the Earth that come bubbling to the surface as lava. This molten rock is over 700 degrees Celsius and can set fire to the surrounding trees in the park. Fragments of the Earth are blasted away as superheated gases erupt from the surface in jets, the searing heat enough to kill anyone unfortunate enough to have set up their picnic blankets nearby. You try to run, but it's futile. There's no direction you can run. The entire caldera is sinking into a vast sinkhole in the Earth, 40 miles in diameter, with upwellings of lava on every side. As you burn to death in the searing molten rock, you thank your lucky stars that you were fortunate enough to be in the epicenter of the eruption. You know that the vast amounts of soot, ash and sulfur dioxide that have been ejected into the atmosphere will trigger a new ice age, devastate the global ecosystem, and that within a few years the rest of humanity will be clubbing each other to death with old car doors and baseball bats in the freezing cold, fighting over the last remaining tin of sardines. Except none of this is especially likely to happen. For a start, there's no way you'd be in Yellowstone Park when its caldera erupts, at least not in a supervolcanic eruption. Supervolcanic eruptions follow similar empirical observed rules to earthquakes in terms of their frequency. But again, these just give an average frequency. So, for example, every so often a bored Daily Mail journalist wanting to clickbait will say that the Yellowstone erupts every 600,000 years. And it's been 680,000 years since the last one. But it's not the same as saying that we're due or that an eruption should be imminent. And unlike earthquakes, there are plenty of unambiguous warning signs that a volcanic eruption is going to occur. We can predict them pretty well. We can monitor how much magma is in the magma basin beneath a caldera like Yellowstone. So at the moment it's around 20% full of molten rock, and we expect that it would need to be 50% or greater for a super eruption to occur. Supervolcanic eruptions tend to be triggered by earthquakes, so we'd need to see several large earthquakes in the weeks or months before. So Yellowstone would be put on high alert, and there's no way you could walk your dog there. So that bit of our scenario is pretty implausible. Indeed, the famous Mount St. Helens eruption in the US in 1980, notorious as the most disastrous one in US history, was predicted. For 2 months prior to the eruption there were earthquakes as the magma began to rise and caused the volcano to bulge, and the volcano had been venting steam and noxious gases for months. Amazingly, or at least I think this is amazing, the ash clouds rolling down the side of the volcano in the weeks leading up to the eruption were dense enough to cause a significant build-up of static electricity. As a result, lightning bolts were striking the mountain, caused by this ash cloud rubbing against the sky. So, it looks pretty apocalyptic. Twilight of the Gods type fire, thunder and brimstone. The kind of dramatic warning signs you might notice. Although the eruption did kill 57 people, some of them were within the exclusion zone without permission, and a lot of them were just unlucky because of the unexpected magnitude of the eruption. An example was the tragic case of a young volcanologist, David Johnston, who had been important in persuading the local authorities to maintain the exclusion zone around Mount St. Helens, even as the expected eruption took longer to materialise than people had thought. But the chances of a supervolcano eruption occurring without some major prior warnings are quite low. When you imagine a supervolcano erupting, you might be imagining torrents of lava burning everything in sight and burying towns and cities as a desperate effort is made to somehow divert the flow or cool the lava down before it hits the suburbs. But the lava is by far the least deadly aspect of a volcanic eruption, because it doesn't affect that large an area. If Yellowstone, or another supervolcano, underwent an eruption, the initial lava flow would only extend for about 30 miles, basically limited to the size of the national park itself. More dangerous to the immediate vicinity isn't the lava, but the pyroclastic flow, the hot gases and rock that are carried along from the volcano. It's this that buried the city of Pompeii when Vesuvius erupted. Pyroclastic flows can even cut across water. In fact, there's some evidence that as they do, the heavier rocks fall into the water evaporates, and this drives the hot and deadly gases faster and further than before. So going across water actually makes them accelerate. Pliny the Younger, who described the Vesuvius eruption, recounted the pyroclastic flow racing along the water. The main risk is asphyxiation due to the lack of oxygen, although as the flows can reach temperatures of hundreds of degrees Celsius and move fast enough to break the sound barrier, if you're close enough, the risk of being caught on fire or simply being swept aside is also pretty high. You might get lucky, and you could be saved by the local terrain. Even a small hill can divert the flow and save you. Or you might be less lucky. We have a first-hand account of being at the outer edges of a pyroclastic flow from the Krakatoa earthquake in 1883, from a villager. We have a first-hand account of being at the outer edges of a pyroclastic flow from the Krakatoa eruption in 1883, from a villager in Sumatra. Quote, "Suddenly it became pitch dark. The last thing I saw was the ash being pushed up through the cracks in the floorboards, like a fountain. I turned to my husband and heard him say in despair, 'Where is the knife? I will cut all of our wrists and we'll be released from this suffering sooner.' The knife could not be found. I felt a heavy pressure throwing me to the ground. Then it seemed as if all the air was being sucked away and I could not breathe. I felt people rolling over me. No sound came from my husband or children. I remember thinking I want to go outside, but I could not straighten my back. I tottered, doubled up, to the door. I forced myself through the opening. I tripped and fell. I realised the ash was hot and I tried to protect my face with my hands. The hot bite of the pumice pricked like needles. Without thinking, I walked hopefully forward. Had I been in my right mind, I would have understood what a dangerous thing it was to plunge into the hellish darkness. I ran up against branches and did not even think of avoiding them. I entangled myself more and more. My hair got caught up. I noticed for the first time that my skin was hanging off everywhere, thick and moist from the ash stuck to it. Thinking it must be dirty, I wanted to pull bits of skin off, but that was still more painful. I did not even know that I'd been burnt." End quote. Not that lava eruptions aren't dangerous to humans, but quite often the longer, continuous eruptions, rather than the catastrophic, explosive types, are more of a concern. Take the eruption of the Laki volcano in Iceland in 1783, an event that may have killed a quarter of the population of Iceland, and was later known as the Mist Hardships. Quote, "This past week and the two prior to it, more poison fell from the sky than words can describe. Ash, volcanic hairs, rain full of sulphur and saltpeter, all of it mixed with sand. The snouts, nostrils and feet of livestock, grazing or walking on the grass, turned bright yellow and raw. All water went tepid and light blue in colour, and gravel slides turned grey. All the earth's plants burned, withered, and turned grey, one after another, as the fire increased and neared the settlements." End quote. It's pretty terrible if you live nearby, but the real danger from a supervolcanic eruption wouldn't be in the pyroclastic flow, although that would devastate the surrounding area. The real danger is from the ashfall in the wider area surrounding the eruption, and the atmospheric effects which can change the climate globally. It's in these areas that any truly apocalyptic scenario from supervolcanic eruption has its bite. So I've been using Yellowstone as our example because it's the best known of the supervolcano calderas, at least in the West. But what differentiates a supervolcano from an ordinary volcano? Generally, a supervolcano has to have an eruption that emits more than 1,000 cubic kilometres of material, or ejecta. For scale, the Mount St. Helens eruption released 4.2 cubic kilometres of material. So we're talking 250 times more for a supervolcano. The supervolcanoes also form calderas, deep depressions in the land, rather than the classic cone shape of an ordinary volcano. As well as Yellowstone, we have the Long Valley caldera in California, the Valles caldera in New Mexico, the Lake Toba caldera in Indonesia, which was the most recent super-eruption around 80,000 years ago. The Taupau caldera in New Zealand and the Aira caldera in Japan round up the list of calderas that could potentially undergo a supervolcanic eruption, although there are others that may now be extinct. If Yellowstone erupted, the ashfall would probably cover most of the continental United States. The ash that makes it far from the park would have risen high into the atmosphere and cooled, so it's not going to set anything on fire, but it could certainly choke off animal and plant life pretty easily. For around 125 kilometres around Yellowstone, the ashfall would be 2 metres deep, There's a horrifying account from Vesuvius of structures literally groaning and collapsing, gradually being buried in the ash, with trapped inhabitants inside. And that's exactly what would happen here. Anything within this radius would be killed, and buildings would be destroyed. For around 500 miles around the volcano, the layers of ash would be 10 centimetres thick, and this would massively disrupt not only daily life, but also agriculture in these regions. Chances are that ash inhalation would be enough to kill you or seriously damage your health by itself. Midwestern farms, where so much of the food supply of the US comes, would be badly threatened. Rivers and waterways would be polluted into an ashy sludge that would be useless for irrigation. We probably all remember the Icelandic volcano eruption with the unpronounceable name. All flights had to be grounded for safety reasons, and if you live in the UK like I do, you know that the whole country practically grinds to a standstill after a couple of inches of snow. At least snow melts, whereas ash certainly won't. Even a few millimetres of ash would be enough to close airports, which would hamper the relief effort. The poor sleepless guys over at FEMA, who do disaster management contingency planning for the US government, estimate that the ash cleanup alone would cost around $3 trillion. There's a great paper online, Modelling Ashfall Distribution from a Yellowstone Super Eruption, by Mastin, Eaton and Lowenstern, where they go through the methodology of predicting how this vast ash cloud might spread under different simulations for the eruption, using the weather patterns and so on in the local region. And they have a big table of cities, so if you live in the continental United States, you can look up precisely how deep the ash is going to be in your city when Yellowstone erupts. Miami will probably be okay, but Salt Lake City is in trouble. As bad as an earthquake can get, it would be quite localised, whereas here we can feasibly see that a supervolcanic eruption could cause death and destruction across most of a continent. But the real kicker is that a supervolcanic eruption would change the climate, and consequently all of the delicate agriculture that depends on it. In the modern world, many humans have become complacent. The greatest revolution in human civilization has been that most of us no longer need to devote significant amounts of time to acquiring food. For many in the civilized world, save for a few lunatic survivalists, hi guys, the skills required to do this have atrophied. When the supermarket shelves are no longer stocked though, any event that causes this is going to cause mass panic, carnage, civil unrest and widespread starvation. It's difficult to see how governments will manage against the rising tide. Any civilization is only a few meals away from anarchy, after all. When Mount Tambora erupted in 1815, registering a 7 on the Volcanic Explosivity Index, which is the second highest, the year afterwards was variously called the year without a summer, the poverty year, the summer that never was, year there was no summer, and 1800 and froze to death. Which doesn't sound like a lot of fun, and indeed it wasn't. Here's an account from the time from a Massachusetts historian. Severe frosts occurred every month. June 7th and 8th snow fell, and it was so cold that crops were cut down, even freezing the roots. In the early autumn, when the corn was in the milk, it was so thoroughly frozen that it never ripened and was scarcely worth harvesting. Breadstuffs were scarce and prices high, and the poorer class of people were often in straits for want of food. So what happened? Well, effectively 1816 was a bit of a perfect storm. The climate had been cooling for a while, the so-called Little Ice Age, and so it was unusually sensitive to new forcings. One of the incredibly complex aspects of climate science is that there are all kinds of feedback effects. The system is complicated. Sometimes it can be deeply sensitive to changes in a certain direction, and the feedbacks reinforce them, and sometimes it's less so. There have been other volcanic eruptions that didn't cause these kind of climatic events to occur, but a supervolcano eruption would probably be much larger. What happens is that vast amounts of sulfur dioxide are released by the volcanic eruption. They shoot up into the stratosphere and combine with water to form sulfuric acid. These little reflective aerosol droplets remain suspended in the atmosphere, in clouds and in the stratosphere, and they reflect back more of the incident solar radiation than usual. They're acting like little soggy mirrors high up in the atmosphere. One of the things I find totally infuriating about the discussion of the climate is the way that statistics get misrepresented. So, for example, Donald Trump, when he abandoned the Paris Climate Accords, issued this really weird and quite contradictory statement. Half the time he seemed to cast doubt on climate change occurring, and we know that he probably doesn't believe in it or hasn't given the issue serious thought. But the other half of the time he said that the Paris Agreement didn't go far enough. Backing this up was the claim that if Paris was implemented, it would only change global average temperatures by 0.2 of a degree. This much? Now, you can debate the politics of Paris, and people have. You can debate whether it's effective, and people have. You can debate whether it would harm the economy, and people have. And you can debate that figure, and people have, with the original researchers behind the paper saying that by 2100 it was something closer to 0.6 to 1.2 degrees. But thinking that 0.2 of a degree is nothing is terribly wrong. You say that and it sounds like nothing. You say that and you think, yeah, I'd have no idea if the weather was 21 degrees or 21.2 degrees. But climate isn't weather. So this year without a summer, with all the terrible effects that we talked about, occurred due to a global average temperature decrease of 0.4 degrees or 0.7 degrees, and the result was widespread catastrophe. Hundreds of thousands of people may have starved to death due to lack of food. This confusion is related to the overall confusion between weather and climate. The number of times you see people saying it's arrogant to predict the weather 100 years from now. Yes, it absolutely is. It's a good job no one is trying to tell you whether it will rain on a given day in 2117. But what they can tell you is that it's highly likely that the global average temperature will be a degree or so higher. What this looks like on the ground can mean widespread droughts, famine, and massive displacement of population. It's not the same as uniformly turning up the thermostat by an imperceptible amount. Okay, rant over. Let's move away from depressing reality and back towards even more depressing fantasies that are somehow distracting me from that depressing reality. What would be the climate effects if Yellowstone or another supervolcano erupted? They'd spew up far more sulfur dioxide, and so the sulfuric acid released would be far greater. There'd be more soggy mirrors and a much bigger radiative forcing, that is, the effect on the net radiation coming down on Earth, than even for the year without a summer. In fact, the fact that so much of the ground would be covered in ash would also change the reflectivity of the ground, which has an impact on climate too. Quote, "The sun was dark and its darkness lasted for 18 months. Each day it shone for about 4 hours, and still this light was only a feeble shadow. The fruits did not ripen, and the wine tasted like sour grapes." That's a quote from 535 AD, after another volcanic winter event was caused by a massive burst of sulfur dioxide being thrown into the atmosphere. But a super eruption would cause an even thicker veil to be raised across the skies. We may already know geologically what this looks like. There was a supervolcanic eruption from Lake Toba, one of the calderas mentioned, around 75,000 years ago. It's estimated that this might have caused global temperatures to drop 3 to 5 degrees Celsius. This eruption was 100 times bigger than Tambora, which caused the year without a summer. Now, as you might have been wondering if you've looked up at the sky lately, obviously the veil doesn't remain in place forever. Most of the sulfur dioxide precipitates, falls out of the sky, on the timescale of a few years. Even the vast amount of stuff kicked up by Toba had probably mostly fallen out of the sky after a few decades. The volcanic winter itself is estimated to have lasted around 6 years. So we can imagine that maybe a supervolcano eruption would be horrendous and cause millions of deaths, but it might not necessarily prove to be the endgame for humanity as a whole. After a few decades, the mirrors would fall out of the sky, and things might begin to return to normality. But this is where Earth's climate system gets tricky. It exhibits a phenomenon called hysteresis. This basically means it can remember what's previously occurred, like a vengeful elephant. If you kick it in one direction, and then try to kick it back in the other direction, it might not return to where it started from. You can trigger events that feed back on themselves. For example, in the case of Toba, people think that Canada may have been partially to blame. Canada. That is, temperatures fell 12 degrees in Canada, the ice sheet became extended, and because ice is highly reflective, it reflects more of the solar radiation, and it caused temperatures to drop even more. You could potentially see the reverse effect if, for example, ice caps started to melt, and so the sea was less reflective. Anyone? So just removing the stratospheric sulfuric acid was no longer enough to return things to the way they had been. For this reason, a lot of scientists think that this event kicked off an ice age that lasted for 1,000 years. This is somewhat controversial. The ice age may have been due to occur anyway for different reasons, but it's a widespread theory. What was the impact on humans? Difficult to tell because we have no written records from 75,000 years ago. But there may be some indirect evidence in our DNA itself. I should point out that this theory is controversial, and it's recently been challenged with some newly discovered evidence. But there's some genetic evidence that seems to suggest that the surviving human population in the world today might descend from a few thousand breeding pairs who lived 70,000 years ago, a population bottleneck. For this to happen, we need to explain why there was such a sharp decline in population, and it does happen to coincide with the Toba event. So theorists suggest that the climate change due to the volcanic winter from this super eruption might have severely limited food supplies, bringing the human race to the brink of extinction. If this is true, it's indicative of the kind of threat that a supervolcano winter could pose to humanity. We barely scraped our way through the last one. So overall, this is a scarier threat than earthquakes, and although it's not especially likely to happen, and may not occur for tens of thousands of years, and would come with ample warning, it's difficult to see how humans would deal with such a volcanic winter. Maybe by then our food supplies will be more secure. We might have ways of keeping people alive and providing nutrients that don't rely on traditional agriculture. What's for sure is that when one of these supervolcanoes erupts, it will destroy everything that's reasonably close to it, coat a continent in difficult to clean up ash, and may begin a decade without a summer. It could even kick us into an ice age that would last for hundreds of years. It might not cause the extinction of the human race, but it would certainly be the end of the world as we know it today. I guess we're just lucky that the timescales for this kind of geological event mean that we'll probably all be dead long before it happens. Thanks for listening to this TEOTWAWKI special of Physical Attraction. As usual, any questions, please send them to PhysicsPod on Twitter or physicspod@outlook.com. I want to know what you think about the scenarios for the end of the world, what you think the favourite is going to be, that kind of thing. And get in touch. Until then, stay safe.
You better make some preparations, there's no time for hesitations. Compile a list of tips.
Our theme music is Get Ready for the Apocalypse by Astrometrics.